Force and its effects. At the end of the topic, you will be able to explain the physical quantity force, describe the various effects of force with examples, calculate the resultant force acting in the same direction as well as opposite direction.
What is force? In simplest terms, we can define force as a push or a pull. A ball will remain in place till it is kicked off with a great force. So, we can say that force is an influence which tends to set a stationary body in motion. This kicked-off ball will remain in motion till it is hit by a bat, which changes the direction of motion of the ball. Thus, force also tends to change the speed and direction of a moving body. Now, after catching the ball, if you squeeze the rubber ball, it changes shape. Thus, force can also change the shape of a body. We cannot see force, but we can certainly see its effect.
In villages, grains are transported by carts driven by oxen. The oxen have to put together greater force to pull the cart that is heavily loaded. To pull a heavy load, greater force is required. Hence, force is proportional to the mass of the object. Moving vehicles like a car, bus and lorries are stopped by applying brakes. Thus, a force is required to stop the moving vehicle. Therefore, force is that which changes the state of rest or motion of a body. In carom board, the coins move according to the striker's hit direction. Force causes motion. Therefore, the direction of motion of an object depends on the direction of force applied. Consider a boy trying to move a fully packed box. The box moves with some speed. Now, another boy joins him. Guess what happens? Of course, the box will now move with greater speed. Because two forces are acting on the object from the same direction, then the forces will get added and the object moves along the resultant direction. If two equal forces are opposite to each other, then the object will not move, because the forces are cancelling each other. The net force acted on the object due to a number of forces is known as resultant force. Now, you might have come to a clear idea about force. Let us see the standard units of force. The unit of force in the CGS system is gram-centimeter per second or dyne. The SI unit of force is kilogram-meter per second or Newton, which is N.
Force acting on an object causes many other effects. Force causes change in motion. Here we see some of the effects of force. When pushing a table, we realize that a force causes change of position. When a cyclist increases the speed of a bicycle, we see that a force causes change of speed. The effect of force causing change of direction is seen when flying a kite. A potter molding clay is an example of force causing change in shape. When a brake is applied to a moving cycle, it comes to rest. This is an example of force causing change of motion to rest. A moving train takes a curved path is an example of force causing change in speed and direction. In this topic, you have learnt force is pull or push applied to a body to change the state of rest or uniform motion. Force can produce change in position, change of direction, change of speed, change of shape.
At the end of the topic, you will be able to identify and define force, differentiate the types of forces. Besides the gravitational force, we encounter several kinds of forces: muscular force, frictional force, force of buoyancy, and viscous force, force due to pressure of a fluid, force due to surface tension of a liquid, and so on. There are also forces involving charged and magnetic bodies. In the microscopic domain again, we have electric and magnetic forces, nuclear forces involving protons and neutrons, interatomic and intermolecular forces. Let us now discuss each one of the forces in detail.
Generally, to apply force on an object, we must come in contact with the object. We could lift a pot and break a glass only when it is made to come in contact. What makes the mango from a tree fall on the earth's surface? Is there anything pulling the mango down? No. The invisible force that is making the mango come down is the gravitational force. This is an example of non-contact force. A non-contact force is any force applied to an object by another body without any contact. Some other examples of non-contact force are magnetic force and electrostatic force. All other forces like the frictional force, muscular force, etc. come under contact force. A force that can cause or change the motion of an object by touching it is called contact force.
Mechanical forces are due to forces we apply from our muscles. We exert our muscles to do work and move to places. Animals carrying loads, throwing, kicking, lifting weights, swimming, exercising. Gravitational force. All objects on the earth, for example, experience the force of gravity due to the earth. It is a universal force. Gravity governs the motion of the moon and artificial satellites around the earth, motion of the earth and planets around the sun, and also the motion of bodies falling to the earth. When a plastic comb is rubbed in dry hair and is brought near bits of paper, they are attracted. This is due to the electrostatic force of attraction. It is the force between charged particles. Bodies with unlike charges attract each other, while bodies with similar charges repel each other. Magnetic force. Any magnetic material placed near a magnet experiences a magnetic force. Magnetic forces can also cause motion.
At the end of the topic, you will be able to define thrust and pressure, state the unit of measuring pressure, list down a few examples of pressure. All objects possess weight. When an object is placed on a surface, it exerts force which is equal to its weight normal to the surface. Thrust is the total force acting or the total weight of the object that is acting perpendicular to the surface. When we walk on sand, we leave footprints due to the weight of our body that acts normal to the sand surface. These footprints are formed due to thrust exerted from the sole of the foot. Another example of thrust is that to stick a stamp on envelopes, we apply a force perpendicular to the surface of the stamp.
Now, let us discuss another important term called pressure. We will see an example to understand pressure. Consider two knives, one sharp and the other blunt. When you apply equal force on the two knives, which will cut the object? Yes, the sharp knife will cut the object since it has small area and exerts great pressure on the object than the blunt knife. Since the blunt knife has large area at the cutting edge, the applied force spreads equally over the area and so the pressure decreases. Thus, it states that the effect of force is more if the applied area is less. This explains the concept of pressure. Now let us see the definition of pressure. Pressure is defined as force or thrust exerted on the surface per unit area. That is, pressure P is equal to thrust T divided by area A. The unit of pressure in CGS system is dyne per centimeter square. The unit of pressure in SI system is Newton per meter square, N by meter square, or Pascal. The unit of pressure is named so in honor of scientist Blaise Pascal.
Pointed shoes offer more pressure because the force is more concentrated as it falls on a narrow surface with less area. Tankers are provided with large base area in order to decrease the pressure. Camels have padded feet with large area so that they don't sink in the desert sands. Flat-footed persons can